Hey guys, welcome back. This is Joel, and in this series, we have been talking about Silver Peak's SD-WAN solution. We've done quite a lot of content in this series. We've done a lot of experiments, and those are already on the channel. This video, we are going to kickstart routing, right? And the first section which we are going to talk about is the OSPF, right? One of the most popular IGPs out there, right? So the main site where we'll be doing OSPF would be the Paris site, right? SP2, SP3, and this switch which I have switch to. It's a IOL switch which I have right now, right? So these are the three devices mainly we'll target, and we'll play around with the OSPF protocol. Okay, cool. So let's get ready. All right, so let's go to our orchestrator over here. Okay, so we'll start with we have SP2 and SP3, right? So we'll select our site, and then we'll basically go to configuration. You will find overlays, there's go routing, and there is something called as OSPF. So we'll go to OSPF, and we have selected SP2 and SP3. So we'll click on the pencil icon for SP2. All right, so first thing we'll have to do is enable OSPF over here, right? And so on SP2, we can basically start by putting a router ID, right? Right, so remember the management interface for this guy was 192.168. So let's use that only as our, I think it was 1.5. Let's use that only as our router ID for this one, right? Let's keep the route map constant here. So you can see, just remember that for OSPF, the redistributing route into OSPF is done at this place, right? So that's one thing about Silver Peak, right? Yeah, it took me a bit of time to understand this as well. The routing knobs, right? Redistributing things into OSPF, redistributing things into BGP. Now, BGP is again a slightly different protocol, right? Because in BGP you can do, you would need some type of route maps per neighbor as well, right? Whereas here you would need just one route map to take care of routes, for a particular OSPF instance, right? So yeah, the different knobs which you have are present at different, places. So I think just pay attention to these knobs and where they are present, because when you are doing similar setup, right, you would need to know that information, right? Where do you want to do certain things which you want to accomplish at as part of your routing, right? So that's kind of important. Okay, so that being said, we've got the router ID in place. Let's add a area, right? Area is very much mandatory, so I'm going to add the area 0. Area type, you can select between standard and NSS. I'm going to use standard. Add, and I think that's predominantly that. Do we need interfaces? Yes, so we're going to add interfaces, and the interface mainly is going to be the LAN side interface, right? So this is perfect. Area ID is already selected for you. Rest everything, let's keep it default. Admin status, make sure it is up, right? Rest everything is fine. So I'm going to hit the add button, and I'm going to hit the save button. So that takes care of enabling what? OSPF on the SP2 instance. The same thing we'll have to do on the SP3 instance as well. So let's do that. Right, so for SP2, for SP3, it looks like things are loading. Is it loading? Maybe not. Let's see. Okay, let's select SP3 here. Okay, so we are selecting SP3, and for SP3 we'll have to kind of do something similar. So enable OSPF. Let's keep the router ID as 192.168.1.6. Route map and all will be same. Area is going to be 0. I'm going to hit this thing. Interfaces is going to be the LAN 0 interface where we are going to enable. Right, LAN 0. Let's keep the admin status up and hit the add button. Perfect. All of that looks fine. I'm going to hit the save button here, and yeah, I think things are good, right? Let's wait for this to go in. All right, so it took few minutes. It actually brought down few tunnels, and I think because of the orchestration being run again. But anyway, I did not really have to do anything. I just waited for a few minutes for things to get stable, and you can see here clearly SP2 and SP3 have OSPF now configured. Under summary, you can see. We can also go to the interfaces tab, and we should be able to see the same. There you go. So we have SP2, SP3, admin status is here. there is area and blah blah, right? The interface state is not showing up. Let's try to get the latest interface state. I'm assuming one of the device probably has to be a designated router because it's a segment, right? If you look at my topology, this there are 3 devices in this segment, right? So you know how OSPF operates. You're going to, in a segment, you're always going to create a designated router. It's a broadcast segment, right? So designated router, then you're going to have a backup designated router, and maybe something like the rest of the routers will be others, right? So you can see here SP2 has the state, whereas for SP3 I think it's still loading maybe, and now let's refresh it once again. Right, there you go. Okay, so not yet. Let's try to refresh from the appliance. Takes a little bit of time sometimes to show that, right? Only SP2 is showing. Looks like the other rest of the 50% is yet to load maybe. We can also go and check on our appliance what's happening on our on our IOL device which we have, right? So this is the switch 2. If you look at the configuration on this one, you can see router OSPF, and we have 1099. Sorry, this is the segment, right? 100.2.0, and you see the LAN segment also has been enabled for the OSPF, right? So if you do show IP OSPF neighbors, you can see the 2 neighbors are showing up here, 1.5 and 1.6, correct? And you can see the state as well, right? So this is the backup DR and this is a DR other, which kind of tells me that the switch 2 is going to be the actual designated router for that particular segment, right? It might take a little bit of time to kind of show up here, but that's the whole idea, correct? Failed to get the data from the 3rd appliance. Okay, it takes sometimes, you know, you would see such kind of errors, but don't worry, just wait for a few minutes and things will get settled down. Let me actually wait for a couple of minutes and be back. Alright, so now you see things have gotten a bit stable. You can see SP2 is showing up as other designated router, SP3 is the backup designated router. Perfect. We can also maybe click on this details data, right, and it will show up some details around like for example here designated router is 2.1, which is actually our switch, right? Switch 2, whereas the backup designated router is the 102, which is SP3, right? So all of that information is shown up there. So our OSPF configuration is perfect, right? So we can go to the neighbors now, and we should technically see some neighbors. Okay, there you go. So we've got with SP2 and SP3, we've got the neighborships, correct? You can see the information clearly present. Don't get confused. This is like telling that SP2 has 2 neighbors, correct? Because SP2 has the switch as the neighbor as well as SP3. So that is the neighbor, right? 2.1 and 102, whereas similarly for SP3 has 2 neighbors, which is the switch and the SP2, right? And the role and everything is clearly mentioned. State is all looking good. And the last thing is probably the areas as well. If you go to areas, ideally all the excuse me, all the appliances are in area 0, and that's what you see here. Perfect. All right, so remember, if you go back to my switch, right, where is it? So if you look at the OSPF configuration here, we know that we have the 10.99.20.0, which is the network coming from the switch. So ideally, if OSPF is all working fine, if we go to the route section, let's go to routes, and if you look at SP2 and SP3's routes, both of them should be learning that specific route, right, which is that 10.99.20, right? So there you go, it is learning from OSPF from the switch, right? Both SP2 and SP3 are learning the same route with the same metric. It's learning from the switch, which means that kind of verifies that, you know, it is working as expected. Also, let's look at the routes which are learned on the switch, right? So if you come down here, show again, show IP OSPF neighbors, we already saw. We should see show IP route OSPF, right? And you see it should be external routes, right? OE2 is what these guys use. Why is it external routes? Because this is how it's happening, right? So you have let me use my pen. So this is how it is. So you've got where were we looking at? So yeah, so we have OSPF on these 2 guys, right? And we are looking at the OSPF routes on this one, right? What's actually happening is remember we also have subnet sharing, correct? That is the overlays control plane protocol, which means all these guys, the SP1, SP2, SP3, 4 and 5, all these guys are using subnet sharing to exchange routes, correct? Which means and what is also happening is this subnet sharing routes are redistributed into OSPF, right? So ideally, when you look at the routing here, you should see all those routes, right, which SP2 and SP3 is learning through subnet sharing. That will also be redistributed into OSPF, and anything redistributed into OSPF will have OE, right? Whether it's OE1 or OE2. In our case, it is going to be OE2, right? I'll not get into details on the difference between OE1 and OE2. I think you will be able to figure that out, but that's the reason we are seeing these routes on the switch, right? So if you look at, if you try to analyze what those routes are, so if you come down here, right, you can see you have received those loopback interfaces, right? 31.1, 31.2.5. You got 3 loopback interfaces, and the rest of the 2 are not learned, because the rest of the 2 are nothing but the loopbacks on SP2 and SP3, right? That is not that is actually connected to the SP2 and SP3. That is not learned through subnet sharing, correct? So that's why those 2 are not getting learned on the switch. You also have learned 10.0, which is coming from the LAN behind SP1, and you also learned about 3.0, which is coming from behind SP4 and 5. You also have learned the static routes, right? These are the 2 static routes coming from where 10, 100, 2s, or so you're learning it from you're learning them from you're learning it from SP2 and SP3, right? But they're actually, I believe in the overlay, it is coming from where? From our headquarters, right? From the data center. That is SP4 and SP5. Okay. And if you really want to understand from where is that setting to redistribute the subnet sharing routes into OSPF, you can actually come to your OSPF neighbors, click on the pencil icon, and you will see that route map, right? Which is present here at the top. So this is the route map, the default route map. If you click on the pencil icon, you will see that you have that information. See here, we are denying the local routes and BGP routes, but we are allowing the subnet sharing, the SD-WAN routes, right? So that's why those SD-WAN routes which our SP2 and SP3 are learning are getting redistributed into OSPF. That's the setting which is making it happen. Perfect. So I think that's actually pretty straightforward, right? All right, as a next step, let's attempt to configure BGP, right? So we'll start with we'll do mainly BGP in the Berlin side, because we have done OSPF on the Paris side. For the Berlin side, let's start by configuring your SP4. Okay, so SP4 and then SP5. Let's use the AS number 65001, right? So let's start with that. Okay, so step number 1 would be going to our orchestrator. Okay, let's close all these things, right? Let's go to configuration, go to BGP. And here we are, right? Let's select the pencil icon beside SP4. And here you can see we have to enable, I mean, if you, I think I had set up BGP in the past, so that's why you can see some values, but ideally this is how you will have your pop-up showing up. So you'll have to just go and enable it, put some AS number, in my case it's 65001, and for SP4 I'll use its loopback IP as the router ID, right? Time to add also make sure that you enable AS path propagate, because when these routes are going to be sent in subnet sharing, right, to the other edge connect appliances, it will be good to have this AS path, because you can do some filtering using that, right? So I'm going to add the neighbors here. So ideally in our topology, this is how it's going to be, right? So we've got use my pen here, one sec. All right, so I've got my pen, right? So the idea here is we've got like these 2 appliances, and then we have the switch 3. On this one, on the switch, we have 3.1. On my SP5, we have 3.102, and other one is, so we are basically going to form neighborship this way, right? So that's going to be the neighborship which we are trying to form, right? So for both the appliances, the switch 3 will be the neighbor. Okay, so let's attempt to do that. Coming back here, so it's going to be what, 10.100.3.1. Peer adjacency is single hop away. ASN is going to be 65,001. We will select peer type as branch. Rest all, let's use default route maps, right? Anything else we want to set up here? Local AS number is already configured, right? Let's also enable next hop self. Okay, let's enable next hop self. Make sure that the admin status is up. Yeah, so all of that is good, right? Just observe the route maps. We'll discuss route maps again, but just to give you an idea, right? So so whenever you do routing in Silver Peak, right, always think about how each of these protocols would interact, right? Because you know that there is something called subnet sharing, which is the control plane in the overlay, right? You also need to understand how your IGPs will interact with it. When I say interact, I mean how you're going to do the redistribution and so on, right? So think in those terms whenever you're configuring. And again, when you look at BGP, right, it's a very interesting protocol because you have per neighbor, you're going to have route maps, right? Unlike OSPF, where you're going to have one route map for the whole OSPF protocol, correct? Because OSPF is a link state protocol and every single device in the area will need to have the same view of the network. So you can't do route maps per neighbor over there. Here it is, in case of BGP, it's going to be route maps per neighbor, right? So you can see this is the inbound neighbor, and in the inbound neighbor, in the inbound route map, we are just allowing BGPs, we are just setting the local pref to 100, right, which is like a default local pref, whereas outbound, right, so when I say outbound, that is towards your neighbor, and outbound, what we are doing is we are allowing something, permit, allow, and enable yes, right? We're not setting any actions, but these are the routes. We are basically routes from SD-WAN, right, which is your subnet sharing routes. SD-WAN, and you can see the various type of SD-WAN routes, how they are going to interact with your BGP, right, with your neighbor, with your peer, right? So that is going to be decided here as well, right? So you can see information about that is present over here. You can tinker with this. We'll probably tinker with this later, but for now, let's keep it default. I'm gonna hit the add button, right? Gonna hit the save button. So that finishes up configuration on what? One of the device. Let's come to SP5 now. Hit the pencil icon again, right? And enable 65,001, right? The router ID is gonna be what? 192. This is gonna be 1.8, correct? And add the AS path, propagate, and we're gonna go with the BGP peers. In peer IP is gonna be 3.1 again, the switch, right? Let's enable peer ASN is 65,001. Let's keep peer type, all of that is fine. Next hop self is enabled. Why next hop self? Because it's iBGP, right? iBGP, you have to have next hop self, else you'll have some very interesting problems. Route maps are gonna keep everything default for now. We're not changing anything. Let's keep rest all to be fine. Okay, so I'm gonna hit the add button and hit the save button. So there you go. So we've configured BGP on SP4, SP5, with my switch as the neighbor. Perfect. So let's wait for this to go in, and there you go, right? So the configuration has gone in. You can see both SP4 and SP5 have peers as 3.1, and you can see the peer state is established. Perfect. That looks good, right? We can actually click on this peer details. Let's get rid of this. So we can click on this peer. Okay, let's click on this peer details, and you should see some information like the router ID, the local routes, right? The routes received, right? So you also see the routes which are received, the routes which are sent, right? All of that information. You've got some updates, results, all of that information about the peering, right? The BGP peering can be obtained from that. All right. So that being said, let's again come back here. Let's actually look at the BGP configuration on our switch 3, right? So this is the configuration on our switch 3, and you can see clearly it's 65,001. The main thing we need, so you can see the neighbor related commands here, which is fine. We also have enabled multipathing, BGP multipathing, because BGP normally selects only one best path, right? I want the paths through both my SP4 and SP5 to be selected as best path. So I've enabled multipathing, but at the same time, important thing is this network has been advertised, right? 99.35 is the network, is the LAN network. If you look at my topology, this is the LAN network which has been advertised into BGP. So ideally, if things are all working, we should be able to ping this particular network from where? From our from either SP4 or SP5, right? So let's do that. So let's come to my this one, right? So actually, right, so let's come to my Berlin site here, and what I'll do is I'll just try to open this SP5, because we have that ping utility, right? So we can try it from there. All right, so we are here. Let's go on to maintenance and ping and trace route. Okay, let's wait for that. All right, so here we'll try to do is 10.99.35 dot, I think what's the IP address we have of the PC, right? We're looking at I mean, we could technically ping yeah, I think it's 11, right, if I'm not wrong. Yeah, so we can now put in the source interface as what? The source interface would be, let's go back to the topology, and the source interface would be, we are on SP5, so the source interface will be 10.100.3.102, right? So let's see if we can ping from that. 10.100.3.102, would that work? Let's check. Right, 10.100.3, yeah, okay, so that looks right. Let's see if the ping works. Right, so the ping is working, right? Let's actually switch to our orchestrator here, right? And we could go to the flows tab, active and recent flows. So that we can actually see this flow which we just now initiated, right? Let's clear this whole thing because it has some filters from the previous this thing. Let's just keep active for now. Let's see if this would work, right? So let's see if this really works. So 10.100.3, yeah, there you go, right? So we can clearly see that, the first one, right? So traffic coming from so we have from SP5 the traffic coming to this guy, right? So let's look at the details of this guy. So we just initiated that continuous ping, and we are able to see here, right? We are able to see the traffic as well. Perfect. And we can actually see all the information, right? The WAN routing information and everything, which means basically what did we achieve from this? That our BGP is really working, and our SP5 has actually learned the .35 network from the switch, and we are able to ping it, correct? And you can see from the routing as well, the next stop is 10.100.3.1, which is actually the switch IP. Perfect. So that's one thing which we could kind of verify over here. We can also go on to the routes tab. Right, so let's go to routes because there's something I want to show you, right? Let's go to routes here. Right, so we are looking at the routing table for the whole, all the appliances, right? So if I search for 10.99.35, you can see right now only SP4 and SP5 have these routes because of BGP, right? Whereas no other appliances have it. So we need to fix that, which means we need to somehow figure out a way to take these BGP routes which SP4 and SP5 have, and we need to advertise it or redistribute that into subnet sharing, correct? So that the rest of the appliances also have these particular routes, right? And to do that, we need to basically go to where? Let's remove the search here. Okay, so once you remove the search, you can right, so we'll have to do this. So again, remember these knobs, right? These knobs are very important. Like I said earlier, remembering where these knobs are important. So what we are trying to do, we are trying to take the BGP routes and advertise into subnet sharing. So we need to do something inside the subnet sharing piece, which is we'll have to do that for SP4 and SP5. So let's select Berlin site and let's go to the pencil icon for SP4, right? So you see there is an option here called default route map to subnet sharing. So I'm going to click the pencil icon here, and you see here the right now for BGP it's denied. So I'm going to click on the BGP one, and I'm going to hit the permit button here. Perfect. So once you hit the permit button, you can update this and apply this. Perfect. So by doing this, so you can see now the BGP routes are going to be learned, right? So into subnet sharing. So I'm going to close this thing over here, right? So and we're gonna hit the save. Is there a save here? Maybe not. Let me just check if it really went through. Let's check once again. Yeah, so now it's BGP is being learned. Great. So I'm gonna hit the close button here. Similarly, we'll have to do the same thing on SP5. So on SP5, click the pencil icon, right? And you can see it's denied right now. I'm gonna hit the pencil icon again, hit the permit, update, apply. All right, close and maybe close. Okay, so now let's come to SP1 again, and if things are all fine, we should have, let's try to hit the search button, 10.99.35, right? So you see SP1 is able to now learn about these two routes from both SP4 and SP5. Perfect. Let's actually remove the filter of this thing and just add it for everything. Alright, so this is something interesting, right? So I've actually filtered on the left hand side for SP1, 4 and 5, and you see now these are the instances where you have the 10.99.35 network, right? Let's try to dissect this. So if I look at take my pen, right? So this is the subnet we are looking at, right? Everywhere is the same subnet. So on SP1, right, the first two entries, this is perfect, right? It is learning through subnet sharing, right? And it is learning from both SP4 and SP5, that same particular prefix, right? So we have no issues with these two things. The next is, if you see this particular entry and this particular entry, we don't have any issues because the next stop is the switch. So this is nothing but directly learned via IBGP. Perfect. But what about these two, right? So let me just, it's a different color. Let me just, one sec, let's just go top, let's use a different color. So what about this entry and this entry, right? So if you look at these entries, you have, it's telling you that SP4 is learning through subnet sharing, right, about this network. So how is it actually working? It's like this, right? So I get rid of all of that. So you have SP4, right, and you also have what, SP5, correct? So you have this switch over here, right, switch 3. So that 10 network, that .35 network is coming in through IBGP, correct? This is fine. So through both the places, through IBGP it is coming in. But after that, what happens, that particular this thing, right? So from here the update is sent to, through subnet sharing, it is sent to the control plane, correct? So this update basically goes to control plane, and control plane is reflecting that update back, correct? Similar thing, this update which is going here is also reflected back. So as a result, you see SP4 is learning about this route both directly through IBGP as well as it is learning through SP5 as well, because of the reflected route. So that's why you see here, you have this entry, SP4 is learning it from SP5 but through subnet sharing, right? Now there are different ways to kind of solve this, ideally, because I would want my SP4 to learn about this directly from here, right? I don't want this reflected route because I'm more directly connected to the switch. Why would I want to send the traffic to SP5, to send it to .35, right? I should be able to directly send it. So different ways to solve this, right? One easier way would be to kind of use there's actually a simple way to solve this, right? So let's remove the search, right? Go back to only SP, or go back to only these sites. Click on the pencil icon for SP4, right? Remember, we have done that AS path prepending earlier, so we'll use that. So you see there's an option here, filter routes from SD-WAN fabric with matching local ASN. So we are telling that if you're learning BGP route, right, through via subnet sharing, make sure that make sure that we don't learn it if it is coming from the same AS, right? So if you see SP4 is also in the same AS with 65001, even SP5 is also in the same AS. So we are basically telling that don't learn those routes, right? And the next thing is we are also telling include local ASN values as you're sending the routes to the fabric. So these both need to be enabled. So by doing this, what we are doing is SP4 will stop learning that same route from subnet sharing because it is directly connected to it anyway, directly connected to the switch, right? So we'll do the same thing on SP5 as well. Different ways to solve this. This is one very simple way. So I'm gonna click here, that's it, hit the save. Perfect. So we have done that. Now if I go back and do the same filtering, right? So let's select SP1, 4 and 5. Remember we had 6 routes earlier. Now if I put a filter, you can see we would have, so it's yeah, I think it has already reduced to what? It's reduced to 5. I think we should get rid of one more as well. Let's refresh, because I just put the configuration, right? So might take a bit of time. Let's wait for some time. All right, there you go, right? Gotta wait for a few minutes, maybe 2-3 minutes for probably the older routes to get refreshed. But now you see finally, if I even select, right, so SP1, 4 and 5, you should technically see only what, 4 routes for it, right? So we have eliminated those 2 routes which were getting learned. Okay, perfect. So that's something interesting. Now what we can also do is, last thing is we can validate what routes are basically learned on this switch, correct? Because we have done all the redistribution and everything which is needed, right? We have redistributed the BGP routes into subnet sharing, and we have seen that those routes are getting learned on, say, SP1. And the reverse, right? We have to see if our switch which is doing BGP with the, our switch which is doing BGP with these two SP4 and 5, is it learning the routes from our SD-WAN, right, from the rest of the appliances. So we can check that, and for that we will have to get onto the switch, right? This is my switch. So let's run some commands, right? So we can do show IP first. Let me get the session up. All right, so we are on the switch, right? So if you run commands like show, if you do show IP route BGP, right, this will actually only show this will not show all the BGP paths, correct? This will show only the best path which has been installed into the routing table. But still, right, you can see, we've got, so you see we've got like all the loopback interfaces here, right? 1, 2, 3, 4, 5, correct? We also have the 10.99.10 network coming from the SP1, right? We also have the 2.0 network coming from the second side, right, the Paris side. We also have the default route which is coming from where 10, it's being learned from SP4, right, not from SP5. Because of this, remember we had set this up, correct? We had set up the metric of 50 for SP4 and 53 for SP5, right? So we have done that previously, so that's why you see this. But if you really want to see individual routes, right, we can actually have a look at this way. So show BGP unicast, I think IPv4 unicast neighbors, and then you can put the neighbor as maybe one of this guy, right? So that's the SP4, right? And we can see the advertised routes, right? So these are the routes advertised from SP4, correct? Sorry, advertised to SP4, right? Similarly, if you probably try the same command, but my bad. So if you change the 3.101 to 3.102, you'll see the advertised routes to SP5. Perfect. We also, if you want to understand a little bit about this default route, right, the default route which is coming from where, from both SP4 and so we can do something like show BGP IPv4 unicast, and if you put /0, there you go. So you're seeing that you're actually learning it from both 102 and 101, but clearly only one of them is being preferred because it's calling it as best, right? Because the metric is 50, here the metric is 53. Got it? So remember we had done this, adding the static route for making our Berlin site as a data center, right? We had done this in the local breakout session. So because of that, this static route is also getting learned via BGP on my switch. Okay. So yeah, why all these routes are getting learned into BGP? It's all because of the redistribution, how redistribution is present in the route maps. In the route maps, we can specifically say redistribute only connected routes or redistribute subnet shared routes. So all of that control is actually happening in the route maps, which we earlier talked about, but you have features for doing all of that, right? Cool. So that's predominantly what I wanted to kind of show you here, right? So we kind of wanted to touch base on OSPF and BGP mainly with this one. Just to recap, whatever we did a lot of things. So just to recap what we did, it's happening here. So that's fine. Okay. Just to recap what we did, right? We actually went about and configured OSPF in Paris. We configured OSPF and we made sure that the subnet shared routes are also getting learned into OSPF, right? I think we did not validate the reverse, which we'll probably do in the route maps video, right? Whereas the next one on the BGP side, we kind of ended up configuring IBGP. We also explored a few things around how to use that AS path prepending, right? AS path propagating, my bad. And how you can use that information to kind of filter out certain routes. We also made sure that the routes coming into BGP are redistributed into subnet sharing so that other appliances have access. We also check the reverse, right? We also made sure the subnet sharing routes are also getting learned into the switch, right? We will exactly see all these knobs being used correctly probably in the next video, where we'll do a lot of route mapping. But always remember that when you're doing routing in Silver Peak, remember, OSPF and BGP are like two important protocols, but there is also one more protocol which is silently working in the back, which is the subnet sharing protocol, right? Which is like the control plane protocol. So you need to always understand or you need to be well aware that when you configure OSPF, say on the LAN side, how do you kind of take these OSPF routes and advertise into subnet sharing? How do you do the reverse? How do you take the subnet sharing routes and advertise back into OSPF? Similar is the case for BGP, right? And you have these knobs. These knobs are there at different places, right? In the UI. So you need to figure out where are those knobs, and you should be well aware of tinkering those knobs so that you will be able to so that you will always have connectivity end to end, right? Because if you redistribute only in one direction, if you don't do it in the other direction, you lose connectivity. So you need to have end to end connectivity. You need to be aware of all the knobs. Okay, perfect. All right, thanks a lot for watching this one, guys, and do come back for more. So this just covers some very interesting OSPF and BGP experiments with Silver Peak. Thank you. Bye.